Hello, my name is Myung-Joo Kim. Above all, it is very nice to meet you in this first lecture class. I have been researched and taught IT, especially information security at Seoul Women's University. My recent research topics are AI technology, AI security, and AI ethics. This is the first lecture of the entire curriculum, so let's learn the basics first. Today's theme is the concept and the history of AI. In this lecture, we will first learn a brief history of AI and related terms. In the history of AI development, various AI types and models have been created. We will compare their characteristics, differences, and the latest technology trends. Then, we will classify AI's learning methods and models, mainly focusing on the machine learning. Finally, we will look into the factors required for successful adoption and use of AI. In this lecture, I am to help you understand these four ideas. And we will cover the following 7 topics in order. First, I will introduce you AI's history and related terms. As shown in this figure on the left, AI first appeared in the 1950s and has continued to develop until now. AI went through 2 winters in the late 1970s and early 1990s. But over the last 20 years, there have been great noteworthy successes and growth. Among them, we should remember following things in particular. There have been matches between AI and humans in specific fields. And it is AI that has consistently beat the best human of each field. For example, in 1997, IBM's Deep Blue defeated Russian chess champion Garry Kasparov. In 2011, IBM's Watson won the American quiz show Jeopardy! In 2016, Google's AlphaGo beat world Go champion Lee Sedol in a final score of 4-1. In 1956, a workshop was held at Dartmouth College. It was attended by influential scholars and researchers, including Professors John McCarthy and Marvin Minsky. The term artificial intelligence was first coined in that workshop. The period from 1956 to 1974 was AI's first prosperous golden age. In 1958, Professor John McCarthy created a language called Lisp, which was widely used in AI research. I also learned Lisp programming when I was an undergraduate. In 1965, ELIZA was developed. This is an AI program that can communicate in English. In the same year, Dendral, the first expert system to help decision-making of organic chemists, was developed. In 1972, an expert system machine that diagnoses blood disease infection was developed and used very usefully. During this first AI boom, USA government agencies such as the Defense Advanced Research Project Agency, briefly DARPA, made a huge investment in AI. As a result, new machine learning techniques such as neural network have emerged, though they were not used universally. In this period, most studies were conducted on symbolism-based AI and opened up the possibility of expert systems. The first AI winter began in the 1970s. In 1969, Professor Marvin Minsky shows pessimism about perceptron, and this had a significant adverse impact on the neural network research. Despite a lot of investments in AI and expectations of AI, we were not able to see satisfactory outcomes anymore. So, in the end, large-scale government investment in AI disappeared. However, rule-based AI, such as the XCON program released in 1978, succeeded and fueled new hope. AI's second golden age came in the 1980s. Companies adopted expert systems, and knowledge-based models became mainstream in AI research. AI's second winter arrived between the late 1980s and early 1990s. As governments and businesses changed their perception of AI, winter came with economic bubbles. Hans Moravec argued new perceptions in AI research and proposed the famous Hans Moravec's paradox. From the mid-1990s to 2010, AI began to successfully produce real-world outputs from the goals set in the past. In the early 1990s, in particular, the concept of an intelligent agent emerged and became common. This is regarded as almost the same concept with the current AI. In 2006, Professor Geoffrey Hinton published a monumental paper heralding the advent of deep learning based on multi-layered neural networks. Since 2011 up until now, deep learning has been highlighted in combination with big data. In 2012, AlexNet, one of convolutional neural network, or CNN, excelled in a famous image recognition challenge, and because of it, the excellence of deep learning came to light. In 2014, Ian Goodfellow announced a generative adversarial network called GAN. This GAN is the first model to creatively generate images using two competing neural networks. Programs such as Deepfake and StyleGAN, which are often used to create fake videos these days, are based on this GAN. In addition, Google's AlphaGo and IBM's Watson show AI's success cases. AI technology for natural language processing deserves attention in the recent development of AI. Language is an important tool that differentiates humans from animals. So, the better AI supports language-based communication, the more it will lay the foundation for further development. In 2017, Google announced the new machine language model called Transformer. Compared to previous natural language processing learning models such as RNN and LSTM, the Transformer can learn with a larger data set. And if additional learning is processed based on a trained model, we can solve various application areas, such as machine translation, document summary, document generation, and video understanding. Transformer-based machine learning models include BERT and Roberta, and recently GPT-3, developed by OpenAI. They are receiving a lot of attention. GPT-3 is an autoregressive language model that generates human-like text. It is a deep learning system for natural language processing that learns 300 billion data sets and determines 175 billion parameter values. Its previous version, GPT-1 and GPT-3 were provided free of charge, but GPT-3 is now available as a paid service. AI models that have been unveiled so far are narrow AI that can be used only for specific problems. But GPT-3 is evaluated to be the closest to strong AI or general AI for natural language processing. Recently, Facebook has released BlenderBot 2.0. This is AI capable of natural language-based chatting on all topics and surpasses the scale of the GPT-3. Then why should we adopt and use AI? According to McKinsey & Company report, AI has achieved the highest productivity than any other technology that mankind has ever developed. And the real growth rate of added value AI has contributed is also high across all countries. AI is a technology that can be applied not only to a specific area, but also to all areas. In particular, AI can be easily applied to any area where data can be collected and accumulated, and great efficiency is also expected. So it is unavoidable to introduce AI. Until now, we have learned AI terms in a brief history of AI. Here, I will more specifically explain terms that frequently appeared in the AI field. In particular, I will introduce 4 terms of AI, machine learning, neural network, and deep learning. Here, each one of these terms includes the next term in order. In other words, AI is the biggest concept, and AI includes machine learning, which includes neural network, which again includes deep learning. Their inclusion is the same as the chronological order in which each technology appeared. Then let's move on to the definition of AI. AI can be defined simply as a machine that mimics human functions. AI predicts, automates, and optimizes human behaviors, such as speaking, recognizing faces, making decisions, and conducting interpretation. Machine learning is a subfield of AI. It can be said that machine learning is a computer algorithm that is automatically improved based on experiences and data. In order for machine learning to make predictions and decisions without being programmed from the outside, it first forms a model based on the sample data called trained data. There is also AI that does not using machine learning. It is called good old-fashioned AI, or simply GoFei. GoFei includes the expert system, rule-based AI, and the symbolism-based AI that appeared in the previous history of AI. This GoFei is still useful in the areas where it is effective to directly input expert knowledge. In particular, it has the merit of being able to explain the reason for automatically determined methods. The neural network is also called artificial neural network, or ANN, because it artificially imitates the human brain neural network. As shown in the figure on the left, the ANN imitates neurons in the human brain. When the neural network is trained with a lot of input data, the weight value of each input and the threshold value of the output are determined. These are called parameters in GPT-3, and a total of 175 billion parameters are provided. Deep learning is part of ANN. However, the adjective deep in the name means that the depth of layers of a neural network. The number of layers may reach tens or even hundreds. Deep learning is also called scalable machine learning. In the existing non-deep machine learning models, humans excessively intervened in learning, so they were difficult to handle if the amount of data increased. However, deep learning models can learn with a large amount of data without direct human intervention. So we call deep learning scalable. Now I will tell you about CNN, RNN, and autoencoder models. They are representative machine learning models that are drawing the most attention. CNN stands for Convolutional Neural Network. CNN models are mainly used for recognizing or classifying images. As shown in the figure, CNN models have a multi-layered structure. The convolution layer that extracts the features and the pooling layer that abbreviates them are repeated in the first phase. In this process, CNN models learn the features of each image. Then the fully connected layer in the later phase classifies images. RNN stands for Recurrent Neural Network. As the word recurrent implies, the output generated at the previous step is reused as the input immediately in the next step, serving as a kind of memory. We call a single memory node a memory cell, and they form a multi-layered hidden layer in the middle of the model. Therefore, this machine learning model is used in areas that require prediction over time, such as natural language processing. If CNN and RNN models are used consecutively, we can develop AI that recognizes features and describes the details of the pictures in natural language. Long short-term memory, or LSTM, is a version that has solved RNN's vanishing gradient problem. An autoencoder is a machine learning model that consists of an encoder and a decoder. An encoder takes inputs such as images and produces features or representation. Then the decoder accepts the output and reconstructs it into the original data. It is mainly used for image processing and noise removing in images. We have so far briefly examined the classification of various AI models and the representative cases in the history of AI. Considering the 70 years of AI history, it is difficult to define AI. In April 2021, the European Union Commission announced a proposal for AI Act. This AI Act legally defines AI as seen here. What is noteworthy is that AI here is defined fairly specifically using the technical terms I have mentioned earlier. In the proposal, AI is defined as software developed with one or more of three technologies. The first technology is machine learning. The second is old-fashioned AI, briefly GAFAI, such as an expert system. The third is statistics-based technology. As such, AI can be defined simply, but also specifically by encompassing technologies that have emerged in history. Now, let's look at the problems that machine learning can solve after learning data. Problems that machine learning models can solve can be divided into regression, classification, clustering, and dimension reduction. Regression problems are about predicting our output values based on input features obtained from data. Classification problems are about determining which class a given input belongs to. Clustering problems are about grouping input data into clusters with similar features. Dimensional reduction problems are about reducing the dimensional space occupied by data. Now let's move on to learning methods used with machine learning models to solve problems I introduced before. Learning methods in machine learning are largely divided into three categories of supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses labeled data sets when training algorithms. There is a kind of teacher who guides the model to produce a desired output according to the input. Supervised learning is used when solving regression and classification problems. Specific examples including classifying email spam and predicting what will happen in the future. It has a disadvantage that you have to attach labels to data one by one, but generally good performance is its advantages. Unsupervised learning allows models to find patterns from input data. Therefore, we use this learning method to analyze unlabeled data sets and solve the clustering and dimensional minimization problems. Specific examples are a recommending system for customers and a system for extracting features from input data. It is good at acquiring and using large amount of data, but it may be somewhat outperformed by other models. Reinforcement learning models learned by trial and error. It trains itself by giving punishment if the output is worse than expected, and giving a reward if the output is good. So it is a kind of supervised learning, but it has no sample data input. For example, AlphaGo, which beat Reschedule in 2016, first performed supervised learning for 12 neural network layers before additionally doing reinforcement learning. On the other hand, AlphaGo Master, which plays a Go match with Chinese champion Ke Jie in 2017, applied reinforcement learning alone to 40 neural network layers without supervised learning. As such, reinforcement learning is effective in solving game AI or real-time decision problems. In the past decade, many successful cases have been announced in terms of AI adoption. And 4 key factors can be attributed to the successful adoption of AI. The first is big data power. The Internet of Things, and the sensor technology have enabled us to collect, store, and manage enormous amounts of data. They are acting as decisive factors for the success in AI learning. The second is innovative AI algorithms and models that have been continuously proposed. As we addressed earlier, the advent of CNNs, RNNs, autoencoders, transformers, GANs, and GPT-3 has resulted in successful AI. The third is the creation of the high-performance computing environment, such as GPUs and cloud computing. Learning from massive amounts of data requires massive computing power. The required infrastructure is now put in place. The fourth is global cooperation system. The open development environment for algorithms and data has enabled global development cooperation, which is also a key factor for successful AI adoption. If you want to successfully adopt and utilize AI in various fields in the future, you must ensure that all of these success factors are well prepared. In addition, it is necessary to manage AI so that it can be utilized in a specific area through the successful procedure. This procedure can be divided into the first part for data and the second part related to the algorithms and models. The key to success is preparing an abundance of high-quality data before selecting the most appropriate algorithm and model for the given problem area you have to solve. At this point, we need an adequate computing environment as well as global cooperations. Finally, let's briefly predict the future of AI. AI can be divided into weak AI and strong AI based on the scope of their problem-solving domain. Weak AI refers to AI that solve problems by limiting their scope to specific area. The current AI is at this level. Weak AI is also known as artificial narrow intelligence, or ANI. The examples of weak AI include Go playing AlphaGo, Bixby and Siri, which are AI assistants that recognize the user's voice on a smartphone, and IBM Watson that diagnoses cancer patients. On the other hand, strong AI refers to AI that shows human-like intellectual abilities in all areas. It can be subdivided again. One is called artificial general intelligence, or AGI, when it shows the same level of intelligence as humans. The other is called artificial superintelligence, or ASI, when it has superior intelligence to humans. Typical AGIs are Eva in the movie Ex Machina and Dolores in the HBO drama Westworld. On the other hand, Ultron from the movie Avengers is an example of the ASI. Ray Kurzweil describes the rise of ASIs as a technological singularity, and in his book, he predicts it will take place by 2045. Now, let me summarize the whole lecture. In this lecture, I introduced a brief history of AI. AI has a history of 70 years and has gone through 2 winters, and now it is producing many results. AI can be classified into good old-fashioned AI and machine learning-based AI. Machine learning can be successfully only with massive amounts of data in the area to be served and strong computing power that support learnings. We are currently in the artificial narrow intelligence era. We are making ceaseless effort to develop future AI technology. So I expect the artificial general intelligence era will come soon. If you want to know the content mentioned in this lecture in more detail, please find the materials or website listed in the following references. Thank you very much.